Section 6.3 is called exponential functions. And with this section, we have some problems that we're going to handle using the exponential function properties. The first question is very easy. If you have 8 to the power of x is equal to 8 to the power of 6, then what must be the x value? When you have an exponential equation, if the bases are the same, powers have to be equal to each other. So when I look at the first side of the equation, the first side has an 8 as a base, and the second side has an 8 as a base. So that means x must be the same thing on the other side. So x value will be equal to 6 for number 1 on the homework question. So for number 2 here, we have a very similar question. And then the question looks like this. I am going to copy it to the board. So number 2 is a very similar question. So for this question also, 11 to the power of x is equal to 11 to the power of 9. So it says solve this equation. And what is the solution set? When I check the exponential equation, the base is 11 on the first side and the base is 11 on the other side. So the powers have to be equal to each other. So the power on the first side is x, and then the power on the other side is 9. So x must be 9, and this is the only possible value for 9. So the solution set is only made up of one number. For third question, what I got on my assignment is something looks like this. For number 3, I got a question like this. It's 3 to the power of negative x, so it's 3 to the power of negative x equals to 81. So finally here, we see something which is not in the format of question 1 and 2. It's actually a different question this time. So the base on the first side is 3, but the base on the other side is 81. So they are not equal to each other. So I can't just go ahead and set the powers equal to each other anymore. So I need to change 81 in a way that it has the same base as the first equation. So when we think about the powers of 3 to the first power is 3. 3 to the second power is 3 times 3, which is just a 9. 3 to the third power is, that means I need to multiply the 3 times by itself. So this is what it means. And then we already know that 3 times 3 is 9. And then when we multiply by 3 one more time, it'll give me a 27. And then 3 to the fourth power is, that means I'm going to multiply this one by 3 one more time, and I will get 81. So when I see this question on homework as number 3, so the first side stays the same, but I'm going to change 81 as 3 to the fourth power. Now I have an exponential equation when the bases are the same. Since both bases are number 3, I can just set the powers equal to each other. So the power on the first side is just negative x. And I'm going to set this equal to the power on the other side, 4. So negative x is equal to 4, but I need the x. So I'm going to divide each side by negative 1. So negative divided by negative is still positive, so this just gives me an x. And then 4 divided by negative 1 is negative 4. This is how I am going to answer question 3 on the homework. When the bases are not matching, I'm going to try to put them in common bases. So for question 4 from the homework, it looks like this. 3 over 4 to the power of x is equal to 27 over 64. Again, the question is, I need to solve this equation. The base is here 3 over 4, but the base is here 27 over 64. So this base has nothing to, this base doesn't look like the base on the first side, but I'm going to keep thinking if there's any way I can change this base to something like 3 over 4. If I think deeper, 27 over 64, so 27 means 3 to the third power, and 64 is 4 to the third power. So when I multiply the 4 3 times by itself, I get this number. When I multiply the 3 3 times by itself, I get this number. So since both of them, they have the same power, because of the properties of exponents, I can express this number as, I can just write the 3 over 4 just one time, and then 3 over 4 will be raised to the third power. So mathematically, this is the same thing as this one. So I know that 27 over 64 is the exact same number as 3/4 raised to the third power. When we go back to the question again, so I have 3 over 4 to the power of x, and we didn't want to change this as 27 over 64. We wanted to rewrite it as 3 over 4 to the third power. Now, when I look at this exponential equation now, they do have the common base. Because bases are the same, that allows me to set the powers equal to each other. So the power on the first side is x, and I'm going to make it equal to 3, the power on the other side. So x equals 3 is what I need for question 4. Question 5 on the homework is, so when you move further down the homework, the questions will get a little bit harder than the first few. So number 5, I have 2 to the power of 2x plus 1 is set to 8. And the question says solve this equation. So the base value here is 2, but the base value on the other side is 8. So this doesn't allow me to set the powers equal to each other yet. So I'm going to keep thinking if I can change 8 with the base number 2. And if we write the powers of 2, 2 to the first power is 2, 2 to the second power is 4, and 2 to the third power is not a 6, because we don't multiply 2 and 3, but in fact, we multiply the 2 3 times by itself, so that's a 4, 4 times 2 is 8. So the 2 to the third power is an 8. So I'm going to rewrite the problem. The first part doesn't change, but instead of 8, I want to just write 2 to the third power. The reason I wanted to change the 8 to this format, because when the bases are the same, I can set powers to equal to each other. So the power here is 2x plus 1, and I'm going to set this equal to a 3. So 2x plus 1 must be equal to a 3. And now I can solve this equation for x. So we will subtract 1 from each side. So 2x is equal to a 2, and then divide each side by 2. So x is equal to a 1. This is how we get question 1 here for number 5. So for number 6 now, here is what I got on my assignment when I opened it. I have 13 to the power of x cubed. So the power is x cubed on the first side. And then on the right side, I have 169 to the power of x. So this is the exponential equation. So when I look at this equation now, the base is 13 here, and the base is 169. As always, I am going to try to make them the same number so that I can set their powers equal to each other. 13 is a prime number, so it's going to stay as it is. But when I think about 169, it's 13 times 13. And that means I can express the 169 as 13 to the power of 2. That's 169 can be expressed as 13 to the power of 2. So we're going to copy the first one. And then for this number, I'm going to write 13 to the second power. And then I'm going to raise it to the x power. So the first side is 13 to the power of x cubed. And then on the right side, the base is still 13. And then 2 times x is 2x. So now I have an exponential equation when the bases are the same. Both of them has 13 and 13. So this allows me to set the powers equal to each other. So the power on the first side is x cubed, and power on the right side is 2x. So now my duty is solving this equation I see on the board. Since this is x cubed, this is 2x, so the first step will be bring down the 2x to the first side as minus 2x and set this equation to a 0. Now x cubed and 2x, they both have an x in common, so I can factor the x, and then this will give me x squared minus 2 equals to a 0. Let's check my factoring. X times x squared is x cubed. X times negative 2 is negative 2x. Now, because of the zero product property now, and I did factor this properly, the first factor x must be set to a 0, and this already gives me an x value to use. X can be a 0, and then the other factor, x squared minus 2, must be set to a 0, which allows me to set x squared to be a 2, and x will be equal to plus and minus square root of 2. So that means the solution set for this question is, when x is a 0, the equation will work. If we plug in a 0 for x, it's going to work. Or if we plug in a negative square root of 2, it's going to work. Or if I use a positive square root of 2, it will work for question 6. That's how we do question 6 on the homework. Let's move to question 7 next. And then question 7 on the homework, the numbers I got is, I have a 32 to the power of negative x plus 36. And I will set this equal to 128 to the power of x. So I'm going to solve this exponential equation. So base number is 32, base number is 128. 128 is not a power of 32, but both of these numbers are power of 2. So let's just again identify the powers of 2 here. 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32, and 2 to the sixth power is 64, 2 to the seventh power is 128. And I don't need to continue anymore because I know that now 128 can be changed by 2 to the seventh power. So instead of 128, I can write 2 to the seventh power. Now I can raise to the power of x. And then 32 can be changed as 2 to the fifth power. So instead of 32, I'm going to write 2 to the fifth power. And then I'm going to raise this to a negative x plus 36. Now, the base number is 2. According to the properties of exponents, when a number has 2 powers, we just multiply them. So I'm going to multiply 5 by negative x, which gives me a negative 5x. And then I'm going to multiply 5 by 36. Positive number and positive number, so the answer will be still a positive. 5 times 6 is 30, 3 is the carry, that's 180. So this will be the finalized power for 2 on the first side. On the right side, the base number is still a 2, but then the final power is 7 times x, which is 7x. So I am at the position where I want it to be. If the bases are the same, this allows me to set the exponents equal to each other. So the exponent on the first side is negative 5x plus 180. And the exponent on the right side is 7x. So since these two are equal to each other, we can just add them. So I will only have 180 on the first side. And 7x and 5x, when I combine them, that's a total of 12x. So the x is still not alone, so we're going to divide each side by 12. So x is finally alone, and when I divide 180 by 12, I believe it goes in 15 times. So the expected answer for this question will be 15. The solution set for number 7 will be just 15. And this is how I am going to answer number 7 on the homework. Number 8. For number 8, I got this question on my assignment. It's 3 to the power of x squared minus 39. And then we want to set this equal to 9 to the power of 4x. So when I look at this exponential equation, the base is 3 here, the base is 9. So I have to do some stuff to get them the same number. The only thing I can change here is 9, because I know that 9 is the exact same number as 3 to the second power. So the first part is going to stay the same. But on the right side, instead of 9, I just need to write 3 to the second power. And then this whole thing will be raised to the 4x power. So now, the first part stays the same. But on the right side, the base number is 3. And then 2 and 4x, when I multiply them, that makes a total of 8x. Now, when the bases are the same, I can set the powers to equal to each other. So the power on the first side is x squared minus 39. And I can set this to an 8x. So this is little challenging than the other equations because here we're going to get a quadratic equation. So x squared stays here. I'm going to bring down the 8x as negative 8x to the first side, and negative 39 will stay, and I will set this quadratic equation to 0. So when I factor this, I can set each factor to 0. I am going to need two numbers. When I multiply them, I get a negative 39, but when I add them up, their sum is negative 8. So it's going to be negative 13 and positive 3. So when I multiply these two numbers, the product is negative 39, but when I add them up, the sum is negative 8. So this allows me to set, so first factor will be x minus 13, and the other factor is x plus 3. And we're going to set them to a 0. As you know, solving this quadratic equation requires me to set each individual factor to a 0, then solve for x. This one is x must be 13 because 13 minus 13 is a 0. And here x must be a negative 3 because negative 3 plus positive 3 is a 0. So this question returns a 2 answers to me for this question. I am going to move to the next one on the homework, which is question 9. So for question 9, what I got on my assignment is I have 4 to the power of x times 2 to the power of x squared. This is set to a 16 to the second power. I need to solve this exponential equation. Now, we have a very important rule for exponents, if you do remember. So if I have 2 to the third power and I'm multiplying it, let's say, by 2 to the fourth power, when we multiply the exponents, we add the powers. So this question is going to give me the answer of 2 to the power of 7, because all I have to do is 3 and 4 will be added, and I will get 7, and I will copy the same base. So here I'm trying to multiply two exponents, but they don't have the same base yet. So I'm going to change the 4 as 2 to the second power. 2 to the second power is still a 4, and 4 has a power of x. On this one, I'm just going to copy it. I have 2 to the power of x squared. Again, I want to change 16 as a power of 2. 16 is 2 to the fourth power. So this is still a 16, and 16 has a power of 2. Let's organize what we got here. So 2 is the base. Now I need to multiply these two things, which will give me a 2x times. Again, the base number is 2, and then there's only one power here, which is x squared. And then here the base number is 2, and I have two powers that I need to multiply. 4 times 2 is 8. I can set the powers equal to each other only if I have one exponential term here. But currently I have two exponential terms that I need to organize further. Because the base is 2, I'm going to copy the same base. The rule is here, when we are multiplying two exponents, we have to add the powers. So I need to add the 2x and x squared. So because these are not like terms, their sum will be just x squared plus 2x. So I'm just adding them, and I'm showing that I am adding them over here. And then this will be set to a 2 to the power of 8. Finally, I am in a position that I have one exponential term on the first side, one exponential term on the other side, and they have both common base. This allows me to set their powers equal to each other. So the power on the first one is x squared plus 2x, and the power on the other side is 8. So I'm going to set them equal to each other. So I'm going to keep the x squared plus 2x, bring down the 8 as minus 8, and I will set this to a 0. Now, if I work on the factoring, factors I need is x plus 4 and x minus 2. Again, how did I get these two numbers? When I multiply positive 4 and negative 2, the product is negative 8. And when I add these two numbers, their sum is 2. This is how we factor trinomials when there is no coefficient in front of the x squared. Finally, I have these two linear factors that I can set them to a 0. So x plus 4 will be set to a 0 to solve for x. So x will be just a negative 4. The other factor I need to solve is x minus 2 will be set to a 0. So x will be equal to a positive 2. For question 9, the solution set for this problem is one of the x value will be a -4, and then the other x value will be +2, and this is how I am going to do number 9. So now I need the last question to be solved, number 10. So when I look at the homework I opened on my other screen, my number 10 showed up this way, e to the power of x. So you're going to understand the value of e. E is called natural number in math. It's called natural number. It's not equal to a 2. It's not equal to a 3. Its value is about 2.72. 2.72. There is more. So you can ask actually to a calculator what is the exact value of E. So if you go to our Desmos online calculator, and then if you just here type E from your keyboard, the keyboard will tell you that, the calculator will tell you that E is a spatial number. Its exact value is 2.71828182.846, and it continues here. And the math people just round it to 2.72. So therefore here, E is called a natural number, and its value is about 2.72. So here, once we have if you go back to the problem, so the only difference here so far is instead of giving the base a whole number like 3, 4, 5, they just use the spatial number e, but it's still a number. And then the right side is e to the power of 3x plus 4. Although E looks like the question is a difficult question, this is a very simple question. All I have to check is, do they have the same base? When I check the base on the first side, it is number E, and the base on the other side is number E. So the bases are the same, so I don't have to do any other manipulation. So the power on the first side is X, and power on the other side is 3x plus 4. And all I have to do is set them equal to each other and solve for X. To solve for X, we're going to subtract 3x on both sides. This will give me a -2x, and then this is a +4. Now I'm just going to divide each side by -4. So x will be equal to positive number divided by negative number is negative, and 4 divided by 2 is 2. And this is how I am going to solve number 10. I wanted to introduce you natural number e here, because when we move to the logarithms, we're going to use this natural number a lot. So it is a good idea that you get yourself familiar with natural number e. And this is going to be the end of section 6.3 exponential functions.